Well, hi, good morning, and thank you so much for joining me here in my shop. Today is May 11th, and last night, uh, during a non-cloudy period, my wife and I got outside and we saw the aurora, which was probably seen by hundreds of millions of people, I would think, because it's all over North America. And not very strong here. You can definitely see it. Just kind of a pale greenish color all over the sky. The whole sky kind of glowing with some strips in it. That's what it looked like here. And then clouds moved in a little later, and then that was the end of that. So, but here's the interesting thing. If you're a radio person, did you try listening to shortwave last night? I haven't tried today yet, but I certainly tried last night, and virtually zero shortwave reception on any band. But here's the most interesting thing. So I listen to broadcast radio, and I try to, make I keep a record of the stations I've heard on just regular broadcast AM radio. During the day, there's about maybe 20 stations I can pick up. It's the same stations every day. It's the same signal strength every day. It's the same thing every day. And then at night, just as the sun goes down, a whole bunch more stations show up, basically one on every frequency on the broadcast band. So during the day, looking at my waterfall display or whatever on my SDR, I see a few, and then at night, these other ones crawl up inside, and stations at virtually every frequency I can pick up and identify a station. Last night that didn't happen. Last night, when I checked this on broadcast, instead of seeing a signal on virtually every frequency across the broadcast band, it looked the same as it does during the day. There were no long distance broadcast signals at all. So I imagine what that means is the ionosphere was so severely affected that it didn't behave in the normal way at all. And the result of that was, I guess, the radio signals are going right through the atmosphere and disappearing. I kind of would have thought the opposite would happen, that this would charge the atmosphere and then it'd be more mirror-like, although I don't like the idea of thinking of it like a mirror, but it would be more reflective, or at least it would enhance shortwave radio. But no, the opposite happened. Completely wiped it out. So, okay, now, enough of that. There's a good chance this is the first video of mine you've ever seen. You're interested in this radio, and so you've found this video. If that's the case, and you're not a regular viewer, you won't know that I don't edit these videos much at all. Very, very little, in fact. So, and I really don't know what's going to happen. I don't plan these out other than, just in the simplest of ways. Like today, I'm going to inspect this radio. That's my plan for today. Not too much more. So because I don't edit the videos, sometimes they slow down a little bit. So often I'm saying things that aren't true. I'm mistaken. So I'm just putting out the warning flags there. I'm just a guy trying to fix a radio. I'm not the oracle here by any means. There's other guys who are better at this than me, I think, and there's lots of videos made specific to issues that occur in these radios that you can watch for training purposes. But watching my video is more like watching the story of me and the radio, and how do we get along? Do we get along at all? And the good news is most of these radios that I work on, like 99, 98%, I'm able to make them work. Okay. So that's enough of an introduction, just in case you're a new viewer. Hey, look at this guy's using the toilet paper roll technique of bundling your cables. How do you like that? He's also using the rubber band technique. Let's take a look at this wire. Is it in good shape? It sure looks to be in very, very good shape. Just looking for any gross problems with it. No. Well, that's the first thing. And right up in here, perfect. So it actually looks very, very good. Okay, let's look at the radio itself. Wow, this is in great shape. Usually these backs are warped and twisted. There's a slight warping here, but not much. Look at all the news on here. We got to read this in a little bit. Made in Germany. It's now I don't know how to pronounce this word properly. I would call it a Graetz. It's Graets, Graetz. Maybe it's Graetz, and here it says, what does it say there? Dana. Looks like Dana. Danza. Danza. D-A-N-Z-A. Danza radio. And there's a message for me up on top. That's from the owner of the radio. Jim, do not plug in. Burning smell. The last time this radio was operated, and this was a daily operator. I think every day this radio was being used, or so. And one day it produced a burning smell, and that's why it's here. The owner wisely just shut it off, and I don't think he's operated it since the event took place. Wow, so let's look at the cabinet here. So I think this is just run-of-the-mill plastic. I'm looking for cracks in the corners. There's nothing. Let's look up here. Okay, sometimes there's some information here. There isn't. The radio doesn't really have feet. Just, one screw. This one here is sticking out. It's sticking out. This would be a scratcher. You're going to scratch up your furniture with that. It'd be good to put some felt feet on there. Some felt pads probably would be good for it. Okay, let's read what it says. We'll just go this way. So antenna, antenna, antenna. It's in 3 languages here. Earth connection, but what's it pointing at exactly? So there are connectors in there, banana plug style connectors, like this kind of thing here. Okay, so we've got an antenna, and it's showing a high quality dipole antenna. How's it doing that? It's showing well, I think it's showing it incorrectly in a sense. It looks like the lead wire is coming up to the center of the wire, but I think what it really wants to show is the lead wire is coming up to one end, and then you have this wire in your backyard. And notice they're showing double insulated at the ends. Wow, really? You know, the radio really is a secondary factor at picking up signals. It's all about the antenna. The radio can only hear what the antenna hears. So putting up a good antenna is a very good idea. And I wouldn't use one like this anymore. I'm using a different style of antenna. Maybe I'll show it later. What I'm using here, FM, 240 ohm FM antenna. Consumption approximately 26 watts. Made in Germany. Danza, the 808E. The 808E. Before removing the back, disconnect the set from the mains, which is a British way of saying it. Keep dry. Well, I am dry, but don't use this radio if you're wet. Like you come out of the shower and you're still wet, don't use this radio. You gotta keep dry. So there's a window here, and in the window is probably a serial number. There's nothing in there. There's nothing there. So why did they bother putting a window in? Often there's a serial number or something of that sort, which is specific to the actual radio unit that you've got here, but that's kind of odd. There's a sticker from the Canadian Standards Association. I guess they must have tested this radio and it passed. And what's all this sticker? 176 Bank Street, Somerset West. These are some locations. A commercial television and appliance. The guy who sold it. This is the guy who sold it. Ottawa's stereo, hi-fi, and TV headquarters. It is, eh? Interesting. Bank Street. Bank Street is a famous street, and so is Somerset. There's famous streets in Ottawa. Okay. Is there anything else here? Am I missing anything? No secrets here. So it has the kind of cable when you take the back off the radio. This will unplug. Now, a lot of these radios, they will. The back is kind of bolted onto the chassis, but not this one. I don't think. Just here. These are 2 different screws too. I think we should probably take the back off. It's got these tabs which are holding it at the top. You're not going to be able to pull the radio straight out. That's not going to happen. So I'm pretty sure these have to come out. A little bit hesitant because occasionally, more than occasionally, there's an antenna on the back. But I don't see one, so I don't think there is one. If there's an antenna on the back, there's a good chance the back comes out with the chassis. But I don't see one. I see this. Nice radio like this with no internal loop antenna. Maybe it's further in. Let's take it. It's hard to believe they wouldn't have built an antenna into this radio. Okay, you have screws on the bottom, knobs on the front. So the knobs, the glass, the buttons, they're all going with the chassis. So we don't have to pull those off. What we have to do is get the screws out from underneath. I think I've seen the Aurora maybe 3 times in my life. Really only 2 I remember, last night and a few years ago. I was in a friend's backyard and I looked up and oh my gosh, the sky was full of Aurora, these large green strips with big red balls pulsing down them. I've never seen anything like it. Boom, boom, across the sky. Of course it wasn't making any sound, that's just me, but oh my gosh, I don't know what that was. And it went on for quite a while, like about 45 minutes. Just these big balls shooting across the sky. Or lumps of redness. I was hoping to see that again, but you know, just wispy stuff in the sky last night. You see other people make videos, they would cut this part out. But what's happened to me here a few times, I've had the video off doing innocent things like this, and something happens that is of great interest, not on video, and I'm all disappointed because I think it's fun. I think, you know, I'm having fun doing this. I assume it's fun to watch because I'm having fun and stuff is going wrong. I'm having fun and stuff is going wrong. Can we just pull this whole thing? I'm still stuck. No, I want to take this off the back here. What am I talking about? There we go. There we go. There it is. Pretty dusty in there. Set that aside. See a piece of dusty paper here with some information on it. See a wire hanging off here. You can see some kind of tape put on here. I see some unreliable capacitors. These are terrible capacitors that are common in these radios. You can see some shining copper here. Don't know what that's about, if it's anything at all. What else do you see before I pull it out? What is this? Not sure what that is. Oh, that's the end of the antenna. They put a bumper on it here for some reason, I guess. I don't know. Putting it back up? That's odd. Okay, let's pull it out. So the speaker is not coming with it, but often these radios have a long enough speaker wire that you can take it out and swing it. boy. I'm not quite sure what all that is. Just dust. Phew. This is the valve lineup. So it's showing the tubes. And what are they? So this has been wiped off in the past. I can see the wipe marks from somebody. EABC, EF85. Can't read the rest. Okay, something smoked in here. I see it already. I think it's that resistor right there. Wouldn't be too surprising up close to the power transformer. But that may not be the only thing, or that may be something that just got hot and it's not really the smoker. A lot of dust in here. So this is just a ground wire that's been forsaken inside the radio, I'd say. Let's get the close-up camera going. I think it's the only way to look at this properly. So I'm going to just bear with me a moment while I freeze the automatic focus on this camera, which I should probably do always before I start these videos, but I virtually never do. I have to do it like this. Here we go. Well, that's set about like that. Okay, we'll start down at this end. So look at the tuning arrangement here. This string that's coming along. Going around there? That's odd. And then it's pulling this slug out of this coil. Seriously? Okay, so I'm going to tune the radio. I didn't try tuning the radio before. Hold this good and still here. There it goes. So there must be either a string pulling it back or there's a spring inside here pulling on it. Huh. Okay, something new every day already. I've never seen that kind of arrangement. Never ever. Look at how thin this wire is, this string is. In the camera it looks like a rope, but to your eye this is easy to miss. You hook that and break it quite easily. That's a very strange arrangement. Okay, let's look at the rest of the strings here. The strings on some of these European style radios, this one I think was made in Europe, they're scary. They're scary guys. This all looks to be in good shape. Look how they push the ends of the string back under the spring, so they wouldn't be flopping around. I guess that goes to the build quality. These radios are well built, well designed, but they're complicated. Like, look at the string arrangement here. Just that alone is complicated. Okay, we have a tuning capacitor, only has 2 sections. We'll go down through here. So I'm looking for, stuff that generated smoke, basically. Anything in here. So much dust. That capacitor, that's a crap capacitor. It's cracking. Smoke come out of that? I don't think so. Okay, we're getting pretty close to the item I saw. So we're looking basically at the transformer there, and there's another one of these junk capacitors, and look at that. Yeah, that looks like that produced some smoke. I'd say it's a resistor, but can you be absolutely sure? I think so. So something like that, close to the power transformer like this, it's indicating a short of a sort that could damage the transformer if you just left this cooking. It takes time for a big thing like a transformer to heat up. So this capacitor here, the electrolytic one, is probably an important one in the FM detector circuit. It probably needs to be changed. This is the copper I saw. It's not copper. Okay, let's look underneath this radio. Now, somehow I've got to turn it over. If I flip it right on top of itself, it's sitting on this is fragile. I don't want that. If I tip it forward, it'll be sitting on this corner and on this, and I don't want this being in that situation. Put it up on its end. Transformers here, but the end is all complicated. I put it on its back. Well, that looks like the way to go. This would still be pushing though. They put a piece of wood under here. Let's try that. That's enough. Put it on its back. Leave it hanging over the edge here a little bit, actually. I don't know if I need that. But just keep it hanging over the edge. Okay, that's safe. There we go. Ooh, look at the windings here. We can see them. It's another one of those crummy capacitors. Not much underneath here. Let's get the other camera happening. So this radio, judging from the circuit board, it's probably from the early 50s. That would be my guess. And cobwebs all over the place in here. More of these bad capacitors. Not a lot of them. Not a lot of parts in this radio. I'm a little bit surprised. A whole pile of them are hidden inside this can here. So this is the FM tuner can. And hopefully we don't have to do anything with that. Hopefully all I got to do is just basically replace that burned resistor. The can has clips on it, so you can pop this bottom off. And right away you got a string right in the way. Another string. This is another string. Ooh, wait a second. Oh, it's going to these push buttons. Really? No. What would it be? That one. That one's the FM one. You push the FM one and this thing, that's wire. I don't think that's string. This feels like string. This feels like wire. It's definitely wire. Yeah, it's a wire. Locked into there. And this is where these European radios, they go crazy. Come on, couldn't you have come up with something other than this? Okay, I'll push the FM button here. And so it's levering up something on the far side. It's levering up this thing. Okay, let's release it. Come on. Oh, it's moving this this multi-switch here, I think. Ah, sorry. Let's try it again. Didn't hold the camera still enough. Crazy. It's just crazy. Huh. Look at the... so there's a switchblade. So I can tell they're making contact because they're moving as they come into contact with them. Wow, I mean, look at the dirt on that thing. What are all those other switch positions for? They're not hooked up, there's nothing. A little hard getting the camera in there. Okay, well that's interesting. Really quite surprising. I'll finish off my sentence this time. Okay, power's coming in here, disappearing into the tube, following the tube up into this switch here. This is going to be the on-off switch. That's probably what this is then. Yeah, off. It's the off switch. You have to push another one to turn it on. That would be on AM and FM. No shortwave in this radio. Again, suggests it's from the 50s, when the radio manufacturers realized nobody in North America was listening to shortwave. Now, I'm not going to see anything under here, I don't think. Oh, yeah, just that. Crappy capacitor. Okay, the only thing that's showing up at all is the cooked up resistor. So, I think probably the next best step would be to try to find a schematic for this radio and see if we can identify that part and come up with a theory as to why it burned up. Okay. Look at the just looking at the solder job down there. Is that a factory thing? Okay. Schematic. Let me find one. This is the search result from Radio Museum when I searched for Danza. When I searched for 808E, it didn't find anything. So there are three the possible radios here. Which one is it? It's not this R or whatever that is. It's going to be one of these two. So we can click on Picture Gallery. Here's the pictures. This is it here. The 808. You notice there's no E? Here's the 808 with nothing. TR. So if we look, we can see that this radio is the one on my bench. Look at this one. So it's very similar but different. The grill is different. And the most different thing is it has all this shortwave stuff on it. So this version has shortwave on it. This is the European version, one that was meant to be sold in Europe. And the E stands, I'm sure, for export. And so they're exporting this one. This is the one I have, and no shortwave, because. And this is actually later than I thought. This is 59 to 60. I thought it was just a little earlier than that, but. No schematic. No schematic on Radio Museum, so I'm off to find a schematic somewhere else. Okay, so I found something on the Electrotania site. There's the name there in the top left corner, Electrotania. Wonderful site, full of schematics for later radios in the 60s and 70s and on up. So I've already downloaded it, and it's here. Now, is this my radio? Everything's in German. So I've looked through this. I'm pretty convinced this is my radio. I don't know what they're talking about there. But here's a problem. Here's the front. So on my radio there is a grill that runs all the way from left to right. like this one. On the shortwave version we saw on Radio Museum, the shortwave screen looked like this. It had these are characteristic, where to tune to hear a certain city in the world. That's a shortwave band, if you like. It probably even calls it that. I don't know. It's in German. So proper grill, wrong dial glass. But you know what? After you see this, you never see this again in this manual. From then on, all it talks about is AM and FM. Never mentions shortwave. Here's the schematic for it. Even here, especially this diagram here, which shows the component layout, matches exactly to my radio. Here they're showing the bands. So the FM band goes from 90, I don't know what that is, 98 to 105. And the medium wave band goes from 550 to 1450. 1600. I don't know what they're doing here. Maybe, I don't know what they're doing. But where's the short wave? There's no short wave mentioned. And these are the IF frequencies in the radio. There's no short wave band mentioned in here. And if we look at the switching for bands, if we can find it, here it looks like here or there, here or there, here or there. Well, how do you get 4 bands on this radio if the switches only go here and there? They have to go here, there, and everywhere too. But they don't. Look at this, medium wave and FM. So what are they doing in this manual that they have this picture? You got me. And this is for the 808. It doesn't say 808E. So my guess is you stick an E on there and this part disappears. But this shortwave part can't work with this schematic. So I don't know what they've done here. But in any case, I think I've got the right schematic. So we should be able to figure out what this part is that cooked up, which is sitting right in this area here. Okay, I'm going to stop for a bit, and then we'll look for the part in the schematic. So often when I go to have my coffee, I watch videos on YouTube. Here's one I was watching: scientists exploring the bottom of Halifax Harbor. I'll just play a moment of it here.
So this here collects images like the shape of the seafloor, but then
yeah. So not so interested in what he's saying. What I'm interested in is look in the background. Look at that. That's a Graetz radio, not unlike the one I'm working on right now. This is inside this guy's laboratory, and I think in a university. I'm not exactly sure where. In Nova Scotia, though. Anyway, I thought that was funny. What a coincidence, eh? What are the chances that I'd be watching a video that shows a radio so similar to the one I'm working on right now? Pretty small. Okay, let's go back to work. Okay, let's take another look at the resistor here. That's, I assume, is a resistor. You know, it looks to me like a wire wound resistor. That's what it looks like. I think I can see the windings through it there. So it's just located right on the top of the transformer, and it's tied to the far, I'll call it the left terminal, and the, what could be the far right terminal too. It could be. Hard to say what's underneath that capacitor there. Let's come back this way. Now, didn't I see a part? A diagram showing where the parts are? Hey, is that an unburned one there? I don't think so. No. Okay, yeah. Let's look and see on the schematic information again. Okay, it's not showing any components here. Where did I think I saw it? I think I saw something. All in German. Here we are. This is it. This is going to reveal it. We just have to figure out where we are here. So this is that long, oh, Son of a gun. This is the long electrolytic capacitor I mentioned. Probably is part of the FM demodulator and probably should be replaced. Here's another one here. Maybe this is it. One of these. Probably both should go. But unfortunately the diagram doesn't cover the parts that are up on top of the transformer. This is just what's on the board. Phooey. And I don't think there's any other diagrams in here. Yay. Run away from that. Well, that's unfortunate. So we have to rely on the schematic now. So we'll get on the schematic here. I'm going to rotate it so it's more normal to look at. Where are you? Transformer. So here's the transformer. This is showing 220 volts coming in. Gee. Of course, I've got the version for export, so this is set up for 120 volts. But I don't like the differences. Oh boy, how am I ever gonna this is just not gonna help me at all figure this out. I don't think. Oh my gosh. There's no terminals numbered here? Is this the right thing? Have I got the right thing here? It's gotta be. There's something funny going on here. All it's showing is 6.3 volts on this side. Where's the rest of it? Where's the high voltage part? This is the high voltage, right? Wait a minute, can't be. You need a... I don't understand what they're doing here. What is this? This is supposed to be the iron core, and this is the primary, and this is the secondary? Or I'm not interpreting this at all correctly. Like, look at this one up here. So this is the output transformer. That's the primary, that's the secondary, and this must represent an iron core in it. Where's the high voltage winding in this radio? Well, it's got to be feeding the plate. So you follow the plate back, we end up over here. This must be it. How do you get high voltage? Is it auto transformer or it's not an auto transformer? I don't get it. You just go on with the 220? Maybe that's done in Europe. Over here it's done, where you have the 5-tube radios and they just run with 120 volts or less, B+. Maybe that's what's going on here. They're just relying on this. That wouldn't work in the case of a radio made for North America, because you're starting at 120 volts here. And I'm sure these tubes, look at 237. How do you get 237 there? On a single diode. Boy, I don't get it. I don't get it here at all. And this is really bad because it's right in the area where the resistor is. So there's two things here. The resistor may have fried on its own. It may have just gone high and eventually just wattaged itself out of life. Or at least generated smoke. We don't know for sure that it's actually incorrect, because another possibility is something has shorted and is pulling current through that resistor and cooking it. And we need to sort this out. Oh boy. I don't really want to turn the radio on and see what happens. I think we've already seen what happens. A process of elimination. The resistor is burned enough that you can't read anything on it. The others you can read right next to it. Where am I gonna? exactly. How am I going to do this? So I've looked at the schematic, I've looked at the parts list, I've just tried everything to try to get a grip on what this component might be, and nothing. I have no grip. No grip at all. So when I don't know what to do, I just start doing stuff. Or I run and drink coffee, that's another thing. But I've already done that, so let's just measure the resistance of this resistor. We don't know for sure that it's actually damaged. It could be it overheated, but if it's a wire type, that's pretty crummy how that's done. So that's 1350 ohms. There's another resistor right here which isn't burned. Exactly 1K. 1000 ohms. And well, I wouldn't read. Wow. That's supposed to be 1000 ohms. It must be because it's in parallel with something, because the color bands on it, they don't match at all. It's gray, looks like gray, green, orange, which would be kind of a weird thing. 85? 85K? This says 1K. The third band is orange. So how do you get 1K out of that? It must be because it's in parallel with the windings. Same thing with the other resistor I'm measuring. I really can't rely on this measurement at all. So the thing is, if this resistor which burned because something else caused current to go through it, then that something else is what we got to find. Now the obvious thing is that this capacitor, but it's not connected to the terminals of the resistor at all. But who knows what this is doing? I haven't been able to find my way on the schematic. Schematic is not laid out at all the way the parts are laid out here. It's laid out in order to make best use of a white piece of paper. That's what the draftsperson's trying to do. So consequently, a lot of components can be shown far away from where they physically are. Shown on the schematic far away from where they physically are on the radio. And that just confusion, and then do it all in German. Wow. I'm really at a loss here. I didn't even find a diagram that shows these terminals laid out in the way that you could work from it. I didn't even find the high voltage scheme. Hey, where's that rectifier that is supposedly in here? I'll betcha it's down over here. Oh, wait a minute. Hold the fort. Jim's been making a big mistake the whole time. That's the power transformer. This is an output transformer. Thumbs up on this. This makes the situation a lot easier, I think. Because now I'm no longer totally clued out as to what I'm looking at. Well, okay, we'll study the output transformer. We're probably on our way to changing about 5 of these capacitors like this. Output transformer, eh? Okay, well, let's look on the schematic. Study that. Okay, here we go. Again, do they have a little? No, they don't. Do they have a little sub diagram showing the parts that I missed? No, they do not. And what's up here? It's nothing up here. Nothing up here. Just making sure. Just some instructions on how to what? How to pry these things off. How to pry stuff. Okay, let's turn this way, and we want to go look at the output transformer and see if we can, whoops, get anywhere doing that. So when I looked in the parts list, I looked for a resistor with an unusually high wattage. I'm guessing that's the case here. I did find one that said it was 1 watt. All the rest are quarter watt or a third of a watt, according to that. According to what I was reading, according to me. So here's a 1K. and another 1K. How's that going to help me? 400. Let's look at the parts list at that particular part. It's right at the bottom of the list. It's right in here. There it is. Look what it says here. I can't even say that. Schitzer Widerstand. What are these? Is that SI silicon? I don't know what it is. Shortwave? I don't know what this is. Bromine? What are they doing? 1K, 1 watt, type SCD1 Rosenthal. What the heck is that? Rosenthal? How did his name get here? Huh. So is that it? Well, that would be 400. Hey, that's one of the ones we were looking at. 400. See, most of them say this 0.33W, which I have to assume is a third of a watt, is half of a watt. What the K is for is I don't know what the K is for. So if it is, let's look at the numbers again. We'll look at the schematic sideways here. So it's 400 and 401. Now, 400 and 401. So what are they saying? There's 2,000 ohm resistors sitting here. One of them, the color coding doesn't match at all. I don't understand. 400 and 401. 401 is the one I would think would be the high wattage one. No, 400 is the higher wattage one. I have no idea if these are even the right ones, because look at the list of parts here that I had to look through. Oh, there's a 1 watter right there. Another Rosenthal guy. It's a Schitzer Widerstand. Part 54. Wasn't there a show, Car 54, Where Are You? I seem to remember that. Resistor 54, Where Are You? Well, I'm not going to go through this again, but I'm sure if I did, I could find more 1 watt resistors hidden away in this list that I overlooked. 54, right? 54. How did they do the numbering? Sometimes the numbering's done very carefully. Like, for instance, the ones you would find in the top left, and the big numbers would be in the bottom right. 400, that looks like that's about the biggest number. So 54 is going to be back here somewhere up in here. Here we are, 50, 60, 54 right there. Well, that's far, far away from where I'm located. I'm located right on the output. It is mounted right on the output transformer. So you got to kind of bet it's this. Let's see. This is the one that appears to be the 1 watter, and this is a 3rd watter. So assumably this is the one that I'm interested in. Assumably. Big assumably. It's tied to the input side, or the primary side of the output transformer. What else is hooked up to it? There's a diode hooked up to it. Can we trace this somehow and find a diode? And this is probably a risky diode. I don't know. We have to look and find it. There's 406. Well, I don't know. 1K. When I tested it, what did I get? I don't even remember. Okay, so let's try this tracing. We'll follow. So one end of this resistor is tied to the other resistor, and the other end is heading to this diode and also to the filter capacitor. That's another good hint. And this resistor is right between these two filter components, and this one is between the other two, like a pi filter. But instead of drawing them down here, or it might have made more sense to me, they've drawn them like this for reasons, probably for control of white space. I don't know. I'm just talking here, hoping some light is going to come on in my head, but it's lights out here. Let's do the trace. We'll find the other wire on this resistor, the one that doesn't go here, and where does it go? Does it go here? Does it go here? Where does it go? Good luck. Here we go. So of course I don't know how other people might be trying to solve these kinds of problems, trying to identify parts. As far as I know, this is the only way to do it, is to just kind of plug away on it. So let's look. I think I'll just use this camera up a little bit closer. So what do we see here? We see the need for a pointer. Yeah, we'll use this guy here. Okay, so resistor in question is this one, and it is connected directly to this one at this end. The other end is not. The other end is hooked up transformer winding, I assume. That's a transformer winding. But there's a capacitor right here, and then there's a pinkish wire heading down for parts unknown. What is that? That's kind of a weird thing there. Color of the wire heading down is, here, have a look at it there, Mr. Man. Tell me what you see. What do you see there? He has to whisper in my ear. Yeah, I don't know what he said. A pinkish wire going down. Oh, you know what? It's not pinkish. It's actually a stripe. And it's going right. It's heading right under the capacitor here. Can we see that? Can we see that? Okay, remember all the things you noticed about turning it over, Jim. Don't forget. So we want to see it. Oh, way up under there. Okay, let me look again. My eye on the right wire, straight down. Don't break something there, Jim. Hold it. You're holding on to the glass, man. Don't hold the glass. There. Ooh, you're bump. Bad move here. Put it like that. And it resting on the side of the glass. Break the glass, and I'll have some splaining to do. Trying to see it. I think I see it. I think it's obvious. Right here, it's going right to the capacitor. Failed capacitor. Failed filter capacitor. Failed filter capacitor. Can that do it? Well, I think it could do it. We have to look at the schematic too. So I'm going on the assumption now I've identified this because it seems to be adding up. That this is the 1 watt number, was it 401? Resistor. So let's look at it from the point of view of what could cause that to smoke. It is a wire wound resistor, so it can take it. It can take it to a point. It looks like a wire wound resistor. So let's see. The power is reaching this filter capacitor. How? Here we are again. It must be through here. Something I don't understand about this. Let's pretend that here's 245 volts somehow getting here. And I trace the wire down to this terminal. So I think. So the power, so this is the number 1. Usually it's on the left here, right? Usually things are just, yeah, there's no usual, Jim. So here we go. So you have to pull the current through here. So you could get a short. Wow, okay, so it looks to me like the short has to be way down the line here somewhere. Could one of these do it? If this shorted right here, then you would have, yeah, you would have a short circuit right through there. So if this center one were to short, yeah, that would do it. And what about, so this wire carries on along here, and goodness knows there's probably no way to develop a significant short to ground out here. Ooh, what's that? That would be a bypass, electrolytic bypass capacitor on the cathode of this tube. So yeah, that's the best. So that's probably the next best guess. Next best guess is this guy shorted right here. How do we find that out? We put the voltmeter on here and see if it's shorted. We look for a short on either side of the resistor that is hot. Okay, so now this raises the question of how is the chassis handled in here. I see this symbol all over the place. That's either back to a B- type wire. See, it's right there too. Or maybe they say it somewhere what it is. Do they tell you? Or every German knows what it is. Okay, a little funny thing there. I'm looking for a note. Oh, there's a different symbol here. So that'd be the earthing ground. And this is probably the chassis ground. Now, how can we prove that? Let's go back to the power side and see. So, so this shows it tied to the chassis. So I'm guessing in Europe you can't. These things are polarized. So this is the grounded leg of the European distribution system. So they would ground that to the chassis. I believe. I'm just guessing away here. So if this is the case, this is chassis stuff. We'll look in the radio in a moment. Then what's that tell me? What does that tell me? That tells me I just have to read from here to the chassis. That'll go through. We can look at the way this capacitor is handled in terms of the chassis. Okay, let's do that. So there's a lot of preliminary things when you first start working on a radio you got to figure out, and a lot of it has to do with how did they handle the power coming in? What did they do with it? Is the chassis going to be live? This kind of radio, no. The chassis is not going to be live unless something's wrong. Or I undertake some stupid thing. Like, for instance, the plug here. Even though this is not polarized, you can only put the back on one way. So they can control which prong is the ground prong that way. With it sitting here like this, I can easily grab my cheater cord. I just have a plug with some clips on it and clip it on here to energize the radio to work on it, paying no attention to which one's grounded inside the radio. I could do that. I won't. To keep myself safe here, when I'm plugging these things in and working on them on my bench, they're plugged into an isolation transformer. So in fact, chassis voltage, that kind of stuff, not nearly the concern it would be otherwise. So, now, what was I going to do? I was going to try to remember what I was going to do. What was I going to do? I was going to remeasure the resistance of this because I can't remember what it was. Look for a ground on either side of it. Yes, he's remembered. Look for a ground on either side of it. Is that going to prove something? Well, I don't know. If there's no ground, maybe that proves something. Okay, one side. So you think that's a 0? That looks like a 0 to me. And the other side. That's the resistance there, 1300, 1400, 1400. So the two resistors involved, assumably this one and this one, both supposed to be 1000 on that schematic. this guy's not measuring at 1,000, he's measuring higher. Let's go right across it, just to be absolutely sure here. Measuring higher and it's in circuit. So it's going to be that amount or higher. That's not 1,000. But see, if that if 1,000 ohm goes up to say 13 or 14, maybe when it warms up it's 15, 1500, yeah. Maybe that's going to generate enough. It is enough excess heat. I mean, this thing's already prepared to be warm because it's a higher wattage resistor. They expect it to be warm. A little extra current, make it a little extra warmer. It doesn't look like it flamed out. It just looks like it got really hot. Or what's happened here is some other component has failed. Oh, there's one right there. Let's just read across this capacitor, which is right there. It's just yelling at me. Hey, what about me? Using the ohm meter is not the best way of doing this kind of thing, but I'll get my finger on it. So that's 480 ohms. And, you know, who knows what I'm reading because it's in the circuit. See, you know, it's one thing to go ahead and change these and then make an assumption you fixed it. But that's a bit of an assumption there. I'd rather be just a little more sure. So this doesn't look like it's shorted, but that's a pretty low reading for reasons we don't know. This capacitor is not actually tied to either leg of this resistor, but that doesn't really matter either. And what is this doing? Goodness knows. Goodness knows how to handle this. Yeah. Drumming my fingers isn't going to do it. Stop. That's how to handle it. Stop and think. Okay, almost done here. I forgot to do what I was going to do, which was read the resistance from this leg of this burned capacitor to the chassis. The theory being, I'm reading it through the, so this would suggest a short inside this capacitor. That's what I'm deducing from this. 0.5. Okay, let's just put this right on the chassis and see if we get another 0.5. Hey. You're kidding me, aren't you? Is this not right on the chassis? Sure. I got a 0. I got a nice 0 on the meter. Come on. I don't get a 0 here. I get a 0.3. 0.3. 0. Okay, I'm going to leave it right here. Don't really know for sure what's going on here at all. Next step could be, let's just start eliminating some possibilities. And radio at this age, it's probably time for this guy to go anyway. Time for all these to go, that's for sure. But whether they're implicated in this, I don't know. We need to get this guy going, and I haven't even tried turning it on to see what happens. because that's not the best move, I don't think, with this radio. Okay, I'm going to leave it right there, and thanks a lot for watching. Tomorrow we'll get a little more serious at trying to solve the problem as opposed to trying to understand it, and see if we can get this guy working again, and then it's a matter of fixing him up so he's got lots of life left in him again. I think a lot of the parts are just hanging on there. Thanks a lot for watching, and see you on the next video.